Most of us enjoy learning how something works. I'm sure you're no exception. Let's take a look at how SecureAire works. This will be a deep dive into the tech, and I'm sure you're going to enjoy it. First place to start is in understanding what is in the air from a particle perspective. So this graph shows particles from 100 microns on the right, all the way down to 0.001 microns on the left. 100 microns is about the size of something you could see, and then 0.001 microns will be what are called ultrafine particles, the size particles that we breathe and go all the way down through our lungs into our bloodstream. That 1 micron size particle there is significant for a lot of reasons. In this case, it's pointing out that nearly everything is 1 micron and below when you consider the number of particles that are in the air. This shows where viruses exist, about that 0.1 or smaller micron size particle. And so they are among the smallest of the particles that can potentially be airborne and can be breathed in through the lungs and again brought into the bloodstream, affecting every organ in the body. The bottom part of this graph now shows weight. And it shows that the largest particles comprise nearly all of the weight. So if you were to measure particles by weight, which Air Advice does, for an example, a very fine product which I've always recommended, measures particles by weight, micrograms per cubic meter. Micrograms, grams are weight. This shows you that you could get most of the large particles and have nearly all of the weight. So that doesn't tell us anything about the number of particles, particularly the smallest particles. So when you measure particle size and you count the number of particles that are in the air, then you want to do it by count, by number, at different sizes, rather than by weight. So let's go ahead and consider this. ASHRAE says that particles below 1 micron in size are virtually unaffected by gravity and stay suspended in the air. That means most of what's in the air by count at 1 micron and smaller is going to be suspended in the air. Even normal air movement will not shake it loose. I use the analogy of suspended in the air like fruit in gelatin. This illustrates a 1 micron sized particle in a vacuum chamber, meaning there are no air currents to impact it. And it would take 12 hours for a 1 micron sized particle to settle to the ground just based on gravity pulling on it. It has so little mass, so little weight, that even gravity can't move it very, very easily. What SecureAire does, and what any technology that causes small airborne particles to clump together, that agglomeration idea, an important idea, is it causes most of these small particles to collide with each other and to attract one another so they get larger. And when they get larger, then they can get caught up in the airflow. So we use collision and attraction to make particles bigger and move them from being suspended in the air, getting into the airflow and getting back to a capturing mechanism, our cartridge. So the 4 steps then are condition particles so that they're capable of being attracted to each other. Then we cause collisions. They collide, just like traffic in a highway where half the traffic puts on the brakes and the other half accelerates. They're going to collide. Two cars are bigger than one. Then we're going to capture these things in our cartridge and we're going to kill them if they're living, and we're going to inactivate them if they're not alive, with potential of doing us harm, like a virus. Then we're going to do something very special. We're going to transport particles, the smallest ones that are too small to get captured. We're going to send them out and we're going to make them like tiny magnets and tiny sponges and go out and work like little soldiers to go out and attract and absorb particles and pathogens and VOCs until they get large enough to get caught up in the airstream and come back. So let's take a deep dive into every one of those particular steps. So we'll use the idea that opposites attract and likes repel. When you open up the secure air purification system, you see three metal grids. The first is charged minus, second is plus, then we have the cartridge, and then we have a minus grid. So each of these grids gets a strong electrical charge with that polarity. And each of these grids has a couple functions that are going to help us. They all work together. It's an interesting combination of strategies that make the entire secure air system so effective. So the first grid, a minus grid, is going to be where the initial particles that are already heavy enough approach. And if the particle happens to be positive, then it's going to get pulled toward that minus grid quickly. It's going to accelerate. If the particle happens to be negative, then that particular particle will be slowed down. So we have half the particles speeding up, half of them slowing down, and that's what we call collisions. And those collisions make these particles get larger. Larger is good. At the same time, while this is happening, between the first and second grid, something else is going on. The first grid is creating negative ions. The second grid is creating positive ions. And these ions, oppositely charged from the grids, are going to be attracted over to the opposite charge and repelled by the same charge, so that they're going to bounce back and forth at the unbelievable speed of 8 miles per second. So we have literally millions, billions of small ionized particles bouncing back and forth between the grids. Well, if things are going to bounce back and forth and they're oppositely charged, you can imagine what happens next. We make some of them larger. They get larger because of having these collisions in a second way. So we have the particles before they get to the first grid being caused to speed up or slow down and cause collisions. We have particles in between the first and second grid colliding with each other, getting larger. And now we have a significant number of very large particles that are going to have enough mass to break through that second grid. Once they break through the second grid, now they're next to the cartridge. If we think of the cartridge first as a filtering device, this would be a MERV 15 filter, which you know is a very high efficiency rating on any filter. So this is going to capture larger particles very effectively. So these large particles then condition from collisions in two locations, big enough so they get captured on the cartridge. So our cartridge material is not like a conventional filter. Conventional filters use interlaced fibers, kind of woven. And they're designed to capture particles of varying sizes by sifting them out. And once the holes clog up, the efficiency actually increases. The downside of that, as we all know, is if you clog up the holes, you restrict airflow. Restricting airflow is not good for 5 or 6 very important reasons. So that's a conventional filter fiber material. SecureAire's material has over 80 million individual fibers per square inch of material. Imagine 1 square inch, 80 million individual fibers. Every one of those fibers is being stretched and pulled, opening up spaces inside of that cartridge. So it's stretching and pulling. Remember, we're between a plus and a minus grid. So that energy field, like as if you were holding 2 magnets close together, heavy magnets, and you could feel the energy between them until you got them so close that they'd snap together. Well, that energy is causing these fibers to pull out. That opens up space between them, and that allows each fiber to become its own collector. Each fiber will absorb chemical pollutants, the VOCs, and it'll adsorb or attach particles and pathogens around the entire surface area. It kind of looks like this. So imagine there's a fiber. It's being pulled between the minus and the plus grid, and eventually it becomes kind of polarized, as if you were to take a piece of metal and rub it on a magnet. So one end becomes plus and the other end becomes minus. And it's going to be pulled apart. Opposites attract, right? Opposites attract. It's going to be pulled and stretched. And then along come these particles that we've enlarged through collisions, And they include particles like household dust and things like that. They include all kinds of pathogens, and of course, they include the VOCs. And then these things get attracted to the fiber and they get absorbed into it. So eventually they just get kind of soaked in, if you will. And think of this as creating an outer layer on that fiber. And that outer layer now, once it's completely coated, becomes the next layer of coating that where everything else will become attracted. VOCs will be absorbed, and that layer will be completely coated, and then another layer will form, and another layer will form. And we can do all that without increasing static pressure, right? Because as it coats, we're not clogging holes. We're just coating the individual fiber. Its diameter increases very subtly, collecting millions and millions of particles, pathogens, and VOCs, and it won't clog up the way normal filters do. These are our static pressure curves. In fact, these are the maximums, 0.14 inches at maximum airflow. If you put a 3-ton system on 1400 CFM rated, you could actually be down 1/10 of an inch. So we do one more thing, one more amazing thing, and that is we create what we call net neutrals. If a particle is so small that it can't get captured, even by our system, then we're going to do something to condition the particles so that overall it has an equal balance of positive and negative little tiny sites on it. Lots of little pluses, lots of little minus. We're going to balance them out. You can see on the right we have 5 of each. And what we're going to do then is send these out like little soldiers, and they're going to attract things like magnets, and we're going to absorb things like sponges until they get big enough and heavy enough that they have enough mass to get back to the cartridge. And it kind of looks like this. Here we are sending out this net neutral, and we're sending out lots and lots and lots of these, and they're going to attract other particles to it, to the positive and negative sites. And once they're heavy enough and have enough mass, they're going to get caught up in the airstream and get brought right back to the cartridge for collection and inactivation. So there you go. That's how it works, a deep dive. And if you weren't sure before, I hope you are sure now that this provides the safest, healthiest, and cleanest air possible today. Thank you.